Hello class, if you made it this far, this is option number 4, Interactive Smartboard Lesson 1. At this point, you should have printed off your activity option worksheet, which is the one that you see on the screen. And what we're going to do is go through the directions. Now remember, this comes from Physics Unit 1, Lesson 1. And Lesson 1 has to do with the first law of thermodynamics that basically says you can't win. And you should be using your foundation worksheet L1 for this activity. So the directions first say that for this activity, you'll be watching the following video, Smartboard Option 1. This can be found on Moodle. Put your name at the top, your partner's name, the period, and the due date. Okay, so first, number 1, we want to complete the following segments in order as you watch and listen to the recorded presentation. So, as you can see in number 2 here, we're going to go to Teacher's Domain, Energy in a Roller Coaster Ride. Okay, and now as the interactive loads, we're going to view it. And as you can see, this is a roller coaster. Now, like we were talking before, L1 has to do with energy. And energy is an object or thing's ability to do work. So the more energy that we have, the better capability we have to do work. So work is basically a transfer of energy, okay? And there are 3 categories of energy: kinetic energy, potential energy, and mechanical energy. For this, we're going to be focusing on kinetic and potential energy. Okay, so as you can see, this interactive, we have a roller coaster. I'm going to play it. If you look in the circle, you'll see that this is a graph that shows the amount of potential and kinetic energy at certain points on the roller coaster, okay? So this pie chart will show you this amount. I'll play it one more time. You can see this. As the roller coaster goes up, it gains potential energy, and then on the downside, it has a lot of kinetic energy. Okay, so now what I want you to do is you're going to answer the first question, and we'll get out of the interactive first. And now I want you to take a moment and answer question 1. Question 1 says that we want you to define kinetic energy and potential energy using your L1 foundation worksheet. Give an example of each. Okay, so you can pause the video at this point and answer the question in a couple of sentences. Okay, moving on. Now you've answered question number 1. And we're going to move on to question 2 and take a look back at the interactive. Question 2 says, what step on the roller coaster is the potential energy the greatest and why? Well, you should have answered question 1 and found that kinetic energy is the energy of motion. So the bigger and faster something is, the more kinetic energy it's going to have. As for potential energy, this is more based on position or shape of an object. Now, if you remember from the Egglander project, things have a higher potential energy when they're at a higher height. This is gravitational potential energy. So now we'll open this back up. And as you can see, the question said, what step on the roller coaster is the potential energy the greatest? Why is this? I'll go step by step. If you look at the pie chart, you see that the potential energy is quite high at number 1. It is full potential energy. This is because of it is at a high altitude and it is not moving at this point. But once it overcomes this, it will have a high amount of kinetic energy. If you hit play, you'll see that it had a high kinetic energy at this point. I will go back through the steps. Step 1, we're gaining potential energy as we move up in altitude. When we do that, step 2, you can see the kinetic energy, the energy of movement is quite high on the downfall. Okay? At step 2, the velocity is 20 meters per second. Okay, so take a moment and answer question 2, which says, what step on the roller coaster is the potential energy the highest? You should be able to look back and know when that was. What step was that? Okay, you can pause the video at this time. Okay, moving on to question number 3. This says, if the roller coaster is on a track with wheels, what type of friction is occurring? Now, it will be good to know what friction is. If you remember that friction is a force that opposes the motion between surfaces that are touching. So now what we're going to do is we're going to pretend that the roller coaster is on a track that has wheels, okay? Now, if you remember, there are four main types of friction that we went over on the L1 primer worksheet. These four were fluid, sliding, rolling, and static, okay? I'll give you a hint. We're not looking at aerodynamics of the roller coaster. We're not going to talk about fluid friction. So it's going to be something else that has to do with the wheel. So how about you take a moment, you can answer question 3 using your primer worksheet if need be. And you can pause the video at this time. Okay, moving on to question number 4. Now we want you to write down the equation for kinetic energy. This is found on your foundation worksheet. You can calculate the kinetic energy of a roller coaster at step 2 in the animation. Now, if you remember when we look back, this is at step 2. It's at 20 meters per second at this moment, okay? So now if we go back, you can see that the velocity is 20 meters per second, okay? So use this information, 20 meters per second, and the mass of 2,400 kilograms to answer the question. Your answer will be in joules, okay? So both work and energy are measured in joules. You can find the equation to be able to calculate the kinetic energy on your foundation worksheet, okay? So you can pause the video at this time and use your worksheet in order to figure this question out. Okay, now moving on, we're going to take a look at BBC Energy Transfer and Storage. Okay, I'm going to click on the link. So now we're back on the BBC Energy Transfer and Storage portion. There are 3 questions to this portion, and we're going to start. Okay? So first things first, as you can see, they're showing an image of a light bulb. Now, if you remember back to the first law of thermodynamics, it said energy can't be created or destroyed, only transferred. Now, a light bulb actually produces thermal energy through electrical energy, okay? It's an energy conversion. So if you use your L1 Foundation worksheet, the first thing that I want you to do is write down the definition of the first law of thermodynamics. This is found right here. So you can pause the video at this time. Moving on to question number 2, what forms or type of energy are involved with a light bulb that is turned on? Okay, so you saw the image of the light bulb. Now it says, now explain the process of lighting a light bulb through multiple energy conversions. Okay, so I'll give you a hint. We burn coal in order to produce electricity. We then transfer or convert that electrical energy into thermal energy or light energy, okay? So what I want you to get out of this question, which I'm going to help you with, is that we are going to create electrical energy, which will eventually produce light energy, okay? So you can talk about that. Now, the light bulb gives off heat, which is thermal energy as well. So you can pause the video at this time and talk about the energy conversions involved. Moving on to part C. What is the definition of friction? What type of energy was produced when creating friction between stick and a wood? Okay, so we're going to go back to this. This is a fun little interactive that has to do with potential and kinetic energy, but we're going to move on to the next step. Okay, so here's friction involving 2 pieces of wood. What I'm going to do is I'm going to move the stick across this very fast, okay? It says rub the stick on the block. Look what happens. We created fire. Why did that happen? Well, if we go back to friction and the definition, it says it's a force that opposes motion between surfaces that are touching. Well, if you've ever rubbed your hands fast together, you will see that it produces heat. This is thermal energy, okay? So if we look at question 3, which I have circled right here, it says, what is the definition of friction? What type of energy was produced when creating friction between the stick and wood? And we just answered that question, and you can elaborate on that a little bit more. You can pause the video at this time. Okay, now moving on to think energy, types of energy, okay? This is a different interactive where it's going to allow us to match up different types of energy. Now remember, there are forms of energy and there are also categories of energy, okay? These forms of energy include things like thermal energy, chemical energy, electrical energy, sound energy, light energy, and nuclear energy. So now what I will do is I will go into the interactive. Remember, you can click on these interactives if you go to the framework that is on Moodle. Okay? So now you can see that we have to match these. On the right-hand side, this side over here, we have bikers, we have a tree, a spring, and many other different things, okay? So what we have to do is we have to match them up with the other side. This case, it says light energy, okay? So light energy is anything that is giving off light. So which of these would be giving off light? Well, we know that in this case, it is, I'm going to clear this ink here, it is going to be the light bulb, okay? So that's correct. And you'll have to use some of this information to answer a few of the questions. Kinetic energy. Now, kinetic energy, if you remember, it's the energy of motion, okay? Kinetic energy equation is mass times velocity squared divided by 2. So I'm going to guess it's the biker because it's anything that's moving, all right? The next thing is sound energy. Now, sound energy is the production of sound waves by vibrating objects, okay? This case, it's going to be the speakers. Guitar strings do the same thing. Thermal energy, this is anything that gives off heat, okay? This looks like a stove to me. I'm not really sure if it is or not, but that's going there. It's producing heat, okay? Kinetic energy of the particles is the speeding up, okay? The next is elastic energy. You don't have to worry about this too much, but this is a spring. This is anything that's stretched or compressed. And then we have gravitational potential energy, just like the roller coaster. This man, he's at a high elevation on a springboard, and because of his position, he has a high potential energy before he jumps. It's anything that can fall. Last is chemical energy. This is anything that's stored energy that is released by a chemical reaction. And the case of photosynthesis, this can be involved with plants. And obviously, we did a good job, and we got all of these correct. So going back to the question, it says question 1, write down the categories or forms of energy and the notation below, each found on the interactive. Now match the examples next to the category form. Now you can reverse the video in order to do so. You can pause it at this time. Next, we'll go on to question 2, part B. Now we want to give the definition and examples of nuclear and chemical energy. Now what I expect you to do on this is go to your foundation worksheet, look up the definition of chemical energy and nuclear energy. Okay, so I'll give you a hint. Nuclear energy is energy from changes in the nucleus of an atom. It involves fission or fusion, breaking or bringing together the nucleus. So you can give examples of why this is important. Okay, we can produce energy with nuclear processes. Okay, you can pause the video at this time and answer the question. Okay, so now we're going to move into the last portion. This part is part 2, partner reflection interview of the presentation. So you and your partner will work together to answer these following questions. Question 1 is, what are examples of thermal, electrical, light, and sound energy in your home? I want you to give 2 of each, okay? So thermal energy, there's a lot of good examples for this. Something that is producing heat, okay? Electrical energy, I'm sure a lot of you have devices that require electrical energy, at least to store energy on the battery, okay? Like maybe your cell phones or whatever it may be, a computer, laptop, iPad, whatever it may be. Sound energy, well, you might have loud brothers and sisters who produce sound waves, okay? Now you can pause it at this time and talk with your partner to answer question 1. Okay, moving on to question number 2. What did you learn from this presentation about energy, and how does it apply to your life? Okay, so now this is a really good one to talk to your partner about, because I'm sure there's great examples of why what you learned today could be applied to, at least on a conceptual level, to your life. Okay, I can think of many great examples. I personally don't like roller coasters and get really sick, so that is something that I don't really think applies to my life. But I know a little bit more about potential and kinetic energy from that interactive. Okay, so thank you for paying attention. Make sure you fill out the rest of your worksheet. If just as a reminder, if you are having trouble with the equation on part 1, okay, you can find this equation in your foundation worksheet, okay? The equation for kinetic energy, you can find that, all right? And that is all that we have for the presentation.